how does acceptance testing play into the overall long-term health of your electrical system? First, I think we need to do is probably review a second or two about the last session. The last session, we talked about how, our job as maintenance professionals, engineers, technicians, mechanics, is to keep this equipment in service and keep it functioning correctly, protecting people, protecting equipment, and also, it's distributing power. So it's not just a protective scheme. It's a method by which the lifeblood of your facility is transmitted throughout your facility. So it's very important that it distributes power correctly. And while doing its job of distributing power, that it does protect and stand vigil as a sentinel over your system to protect it from catastrophic failure, from overload, from short circuit, and act as a disconnecting device when you want to obviously isolate a particular part of your plant or a particular part of your electrical system from online. Let's talk about what acceptance testing is. We're going to talk about MTS or maintenance testing in a subsequent session. Today, we're going to target acceptance testing and what it does and how it comes to play in the overall plan. So ATS is one major building block in your overall reliability plan, and reliability is what it's all about. But the plant has to rely on this equipment to be an isolation device, a distribution device, and to be an overcurrent or some power parameter protective device. There's lots of things considered to protect your system other than just overcurrent, but primarily we're going to discuss overcurrent today. Testing, everybody seems to think testing is what it's about, and the title is acceptance testing, but it's really reliability. Okay, and acceptance testing is just one tool to make the system reliable. So when you do testing, electrical testing, mechanical testing, whatever type of testing, that just proves the system will function correctly at that moment in time. Reliability is about how do I feel safe and comfortable that my system will actually function and protect my equipment over the period of time that we've set for our maintenance interval, because everybody has a different maintenance interval. Acceptance testing, you're basically starting with the new equipment, and then over a period of time, okay, you'll test it again and you'll start maintenance testing. In that period of time, how do you feel comfortable the equipment will perform? Testing really doesn't do that for you. Testing only tells you today. So how do you basically prove that out to where I feel comfortable that my equipment will properly perform over this length of time? Is that 1 year? Is that 2 years? Is that 5 years? We'll get into that maintenance cycle and how to determine what that time should be in the maintenance part of the presentation, which will be in a month or two. So basically, if I test today, I test tomorrow, I test the next day. If I did a complete electrical test every day, I would feel pretty comfortable that my system was reliable. But you can't do that. So you can only test it one time, and then you wait for a period of time before you test it again. In that interval, you want this equipment to be reliable. That requires a lot more than testing. You cannot test in reliability unless you want to test it every minute, every day, every week, every month, which is not practical. So to make it reliable over this period of time, you have to have building blocks. The ATS or the acceptance testing is simply one building block in that overall plan to make your plant reliable or to make your electrical system reliable. Meaning when the equipment comes in from the manufacturer, you need a starting point to where you believe that the equipment is reliable that day. And then your maintenance plan is how do you intend to keep it reliable till the next maintenance plan, and into the future for 100 years. How are you going to keep it reliable over the next 100 years? And it's your job as a maintenance professional to put a plan in place that'll do that and turn it over to the next maintenance professional that takes your place, because you won't be there in 100 years. When I came into this business 45 years ago, the equipment was being maintained in a certain manner. Today, it's being maintained in a different manner. And lubricants have changed, the equipment has changed, everything has changed over these 45 years. It'll continue to change, but there is nothing on the drawing board today that satisfactorily will replace the air breaker and low voltage and vacuum breaker and medium voltage applications. So what is reliability in switchgear? You cannot test it in. You have to bring it to the equipment through inspections, through proper lubrications plans, through all the things to keep it reliable, but it starts minute one with a credible, proper acceptance test to make sure that at least on day one, you have properly operating equipment. Reliability is about 100% uptime, okay? So between today and when your next maintenance cycle is, we want real reliability, we want 100% uptime. Maybe in some applications that's not practical, but that's what we're shooting for. Here's some of the terms we're going to use. A little clipboard, the function testing, general maintenance, inspect, some eyeballs. These are all the different glossary terms we're going to use. And the task at hand is to make electricity there to the left, to move it, and then use it, okay? Whether we use it in residential or an industrial setting, whatever it is, basically our task is all of you fit in this block somewhere. You're either utility guys, your distribution guys, or your utilization guys and users. And a proper acceptance testing plan is used across all these blocks. You know, reliability and uptime is earned, okay? You earn it by doing the work. You earn it by having a plan, working the plan, and being smart about what you do. And you cannot test in reliability. That means you have to work the plan. You can't test it in 5 years and expect that it's been reliable the previous 5 years if you don't put the work in. And that work is what we're going to talk about today. So it starts out with proper handling, you know. Probably it starts out with buying the right equipment, but everybody doesn't have the option to be involved in that loop. So when the equipment shows up to the plant, how long does the gear sit in storage or on a pad before startup? Does it sit outside? Does it sit in a climate controlled warehouse? Is there heat on it? Can you run heater circuits to it? Can you keep it warm? Did it get exposed to moisture on the way there? Then it gets into, is it installed and set up properly? You know, an electrical contractor that installs this equipment can be very familiar with low and medium voltage equipment. Today, we're talking about primarily from 480 volt motor controls and the 480 volt power panels through 38 kV vacuum and some gas gear. But that's the basic domain we're talking about today. So if I say some that doesn't pertain to 245 kV, so be it. I'm looking at 40 volt through 38 kV in this presentation. So electrical contractors can be very familiar with this type of gear, or they can be first-time installers. And you see that quite often. So ascertain the level of expertise of your contractor, and that'll give you some idea how much time you need to stay hand in hand right there beside him. Is the original manufacturer doing startup? Is the original manufacturer doing startup and acceptance testing? So we're seeing more and more of that, especially in the data center world, where the original manufacturer comes in and convinces the user to allow them to do not only the startup, but to do the acceptance testing. Is that wise? Well, what they offer you normally is an extended warranty if you let them do the acceptance testing. So for that additional warranty, you get some, I would say, advantages, and you get some disadvantages. The advantages might be that you get the original manufacturer's support very quickly when they find a deficiency or a missing component. And the disadvantage might be that, you may not hear about every problem. You may not see every problem because they may handle it internally and not disclose it to you. So there are some advantages and disadvantages with having the original manufacturer involved in the startup and acceptance testing. Myself, I would prefer a third party in the testing side. You might allow the manufacturer to come in and do all the startup, turning over to hand in hand with the contractor, turn it over to the testing company. But I would think you would want a third party tester. Another reason that the manufacturers want this 5-year warranty or want to do this acceptance testing in this startup is when they find a deficiency or a problem, they behind the scenes sometimes can deal with the issue before it's really brought to your attention. So watch that pretty closely. Now, if we talk about the different ways to go about acceptance testing, and we're going to define acceptance testing as brand new equipment. It may have been in storage for some period of time. It may not. So how long was it in storage? How was it stored? Was it stored properly? When you take it out to install it in the switchgear, are there any signs, the telltale signs you see, rodents, moisture, condensate, damage, all that stuff needs to be checked very closely before it's installed in the switchgear because your warranty has started to run at some point along the way. The advantages of a third-party test are if you don't do the testing, then you don't have a starting point, okay? And you need a starting point. You need a base to build upon with your maintenance plan. Because if you know the equipment functioned properly day one, it's a real advantage when a year or two from now you get into timing tests and you realize that it slowed down. If you don't have the initial timing test to determine that, you don't know if it's an atmospheric problem, a lube problem, what it might be that's slowing down your breakers. So it's real important to get all this test data in the beginning. There are some advantages with NETA. They're a broad-based association that has thousands and thousands of combined years of experience, and you get that. All the technicians carry a reasonably credible certification, and I would highly suggest that you consider a NETA contractor. However, if you have a non-NETA contractor you're comfortable with, there are plenty of them that are credible. There are plenty of them that are professional. It doesn't mean that you have to have NETA certification. But I think if you do have a fully compliant NETA company and a NETA level 3 on site, you're probably going to get a reasonable project management. You're going to get reasonable documentation. You're going to get a good job. The non-NETA alternatives, why? Maybe you have a relationship there. Maybe they're local. Maybe they have the manpower available. Maybe they have expertise within this particular system. All these projects are site specific. What that means is no acceptance testing job is identical to the last one. There's always something different. You're near the ocean, you're at altitude, you're in the desert, you're on the top of the building, you're in the basement of the building. All these things make a big difference. Quite often, the equipment is not in a new facility. It's simply a new piece of gear going into an older system. How it interacts with the older system and how the two work together is very important. So there are reasons to pick a non-NETA testing company to do your acceptance testing. And there are reasons to pick a NETA testing company. And all that needs to be factored in, and that decision needs to be made way in the beginning. Baseline to trend is what we're talking about. So you want a credible test. You want all the electrical tests, all the manufacturer's recommended mechanical tests. You want a baseline. You want to know that the day you installed the equipment and you energized it to begin to pass power into your system to go into commercial operation, that equipment operated successfully, that you have ultimate confidence in its reliability. Then the length of the maintenance cycle to where you're going to start maintenance testing comes into play. So it's reliable the day one it's turned over because you've done all the work. You've done the mechanical tests, you've done the electrical tests, you've done the inspections, you've turned it on IR testing, you've done everything you should do, everything you can do. Now the warranty starts to run. The typical warranty might be a year and then 18 months after installation. After purchase, 1 year after installation, it might be 2 years, it might be 3 years. They're all over the place. Know what your warranty is. And we'll get into that in another slide. Always remember that, get a good baseline on the cables and all the insulating systems, as well as the overcurrent protective devices. You want good baseline material. You want to know that the equipment was working correctly day one, because you get into GAE 500, you come back and you test it, and now you've got a problem. You don't know if that problem has manifested itself over that period of time based on some problem in your plant or some operating error, or did it come in that way? The only way you can alleviate and rule out that it came into the plant in that condition is if you do credible acceptance testing day one. Visual inspections, man, there is nothing that beats a good set of eyes, a set of ears, the smell test, proper cleaning in the beginning to make sure everything is clean, everything is installed correctly. All the jumpers are off, all the grounds are correct, everything's installed right, all the wiring looks right, you got the pull test, you've inspected, you've run all the controls. Nothing beats a good visual inspection. So make sure part of the initial acceptance testing is someone that knows what they're doing, that knows this equipment, has looked at every inch of it, and it's been properly cleaned to start with. You see a lot of stuff that comes out of the manufacturer's plants that may have set on the plant floor in the last few years. It may have sat there a year, it may have sat there 2 years, because the construction cycles were so long. A lot of this equipment set on the plant floors a long time. Make sure it's inspected, visually inspected. That's just as important or more important than the electrical tests. You know, warranties start to run at various times. Every job that's purchased by your purchasing department or purchased by your customer has a different warranty clause, and that's negotiated at the time of sale based on the size of the project, the criticality of the project, how bad the manufacturer wanted the job, how bad the user wanted to get the equipment there in a hurry. All this stuff rolls into what package they give you for a warranty. Let's just say that it's 18 months from the time you buy it, 1 year from when it's installed. That's pretty normal. Starting to see some 2 and 3 year stuff, even 5 year stuff now. But the thing you have to realize is what that warranty actually is, because once it starts to run, it starts to run. And once the warranty starts to run, you need to make sure that the manufacturer has done everything that you've found. So let's say you have found 30 or 40 discrepancies in the switchgear. There's 2 or 3 instruments missing, not uncommon. The wires are running through the empty holes. There's a tag on it that says this is being shipped to you. It was back ordered. That happens quite often with new gear because they believe it will get there, get delivered, and they'll have their outside service team come and install that device, okay, before you get to startup. So missing things, any discrepancies you find, make sure it's noted and very carefully stay on remediations of any issues found and documented. Ask for extensions in your warranty if they cannot make that equipment 100% ready for you on the date you plan to go into service. You can ask for the warranty to stand still until they get the equipment completely assembled. If there's a particular missing, the spares aren't there, the breaker tools aren't there, wrong size fuses were shipped, connecting links aren't right, whatever. There can be thousands of problems. Don't be afraid to ask for a standstill or an extension in your warranty if by chance the manufacturer at his problem have not been able to supply you complete gear that is ready to be used and in the configuration you expected. Like we said earlier, inspection, storage, and handling, particularly of the circuit breakers, they come in boxes, crates like you see here at the bottom. What happens there quite often, the switchgear is shipped, sometimes goes directly to the pad. The switchgear is shipped and goes into a storage building. Then that switchgear may get installed on the pad months, I've even seen years, before the breakers come out of the warehouse and get installed in the switchgear. So all sorts of things can happen there: moisture, rodents, dirt, dust, aging, contaminants, all sorts of things can happen to these boxes as they're set and stacked in the warehouse. It kind of depends on, can you get heat on it? Are they in a climate controlled? Are you in New Mexico at 8,000 feet, or are you in Houston, Texas, next to the ocean? Make sure there's qualified people in the loop, not only in the install, not only in the testing and inspection and maintenance, also in the handling of this equipment. This equipment is damaged more often in handling than anything else. We see as much damage in people taking these breakers out of service for testing and maintenance as we see that they're worn or defective or failed in service. So in the early check, look for damage on the boxes, look for discoloration on the boxes, When the breakers come out of the crating to go into the switchgear, be sure there's someone there that can visually take a look at them and make sure not only are they in clean, good condition, but they haven't been damaged and they're properly prepared. You'll also find breakers that are missing components. So it's very important to do those initial inspections and tests. How long was it stored and how was it stored? Two good things you have to know. The next thing is compatibility. Quite often we see breakers that come to switchgear to be inserted in switchgear, and they're either the wrong breaker. Breaker A was supposed to go with substation B. Breaker B was supposed to go with substation A, that sort of thing. So check the compatibility and check for the proper ratings. You should have a schedule of what those ratings should be, and make sure someone with enough experience looks at the breakers to make sure you're getting the proper ratings and the proper cells. Lots of times, and particularly low voltage switchgear, some of the low voltage breakers may have 4-wire ground fault. So if they have 4-wire ground fault, they will have a different sensor and a secondary in the back that feeds the ground fault current into the trip device. You can't just put any 800 amp breaker in any 800 amp cell. So you have to make sure the compatibility is right. I've seen jobs where customers inserted 8 and 1600 amp breakers in switchgear that were set with 4-wire ground into cubicles that were not equipped for 4-wire ground. Therefore, that means they didn't have the ground fault protection in the proper cells. Those sorts of things are the things you have to look for. Make sure the interlocks work, make sure all the secondaries line up and work, make sure everything works correctly, not only with the breaker, not only with the switchgear, but the combination of the two mating together. If they don't, you're going to have problems. Controls and overcurrent protective devices. Look for missing components with new switchgear. Quite often you will find a component that's missing. There'll be a tag on it and the tag says being shipped later. Or it'll be in a cardboard box up in the instrument compartment because they didn't get it installed, but they shipped it with the gear. And you see that more often than you might think. So watch for things that are shipped short. When you do, that's very common now with the supply chain shortages we've had the last few years. So when you see that, you need to stay on the manufacturer to supply that component and get it in before startup day. The equipment may be 2 or 3 months or a year before the actual day you're going to go into commercial use of the equipment. So quite often they leverage that time to ship short components. Make sure you're there. Make sure all the current path and the overcurrent protective devices are tested. A lot of people just come up and finger the relays, push the trip button. If that trips the trip circuit, they believe in it. Actually push current through the circuits. Make sure everything lines up, everything runs, all the metering runs, make sure everything runs. Push current, 3-phase current if available, or there's ways to do it with single-phase current. Push current through these circuits and make sure everything functions correctly in the test mode before we get online, and then it's too late to come back and easily make a correction. Don't trust anything, question everything is something Ernie Showalter taught me. And if you don't question everything, you'll see problems. You see here at the bottom in this little contact block, you see there's obviously 2 blue wires and there's a splice. That's the sort of stuff you need to be looking for. Everything should be continuous circuits, gray, switchboard wire, typically SIS wire, typically. Make sure all the radius bends and all the terminations look right. You see stuff that doesn't look right, then you have to dig deeper and dig deeper. You see all this nice gray wire that's all looped in properly. Then you see 2 yellow wires that are tied into these looms with wire ties going over and clipping into a jumper somewhere. That is a red flag. You need to go back and figure out why that is there, determine if that jumper needs to be there, if those splices need to be there, and was that added way late, way early. So anything like that, especially when you get into the maintenance world, needs to bring a real tag for you to be careful of. Look for strange added wiring, look for colored wires that don't match, look for splices, look for anything that looks irregular. A lot of people take and pull on the leads or whatever, but usually if you look at the wiremanship, the workmanship and the wiring, it's pretty easy to tell if you've got quality equipment or not. It's pretty easy to tell. During COVID, for instance, a lot of equipment was built with casual labor instead of their normal wiremen. So be careful of that equipment that's out there that's coming into service right about now. Reliability is a sense of safety and a sense of calm. And what we're trying to do is express the fact that we want the equipment to be reliable between maintenance cycle, not just one day, the day you test it. To do that, you have to have a base starting point that's reliable. And that's what we're talking about for people that come in late. Cables and bus ducts, you have to figure that in as part of your system. The cables run into armor cable, they run into bus ducts, they run up to a mile in the plant, 2 miles. In that, there are splices, there are manholes, there are terminations. There's all kinds of things in the cabling systems that need to be checked and tested. Most early failures are termination errors. So look at the quality of the terminations. A lot of that can be picked up with PD testing, with high frequency PD testing. But basically use your eyes, inspect the cables, inspect the terminations, inspect everything, trust nothing. And a good PD test will get you a long ways toward determining if these cables have been overbent and there's been radius errors or any of that sort of thing. Bend radius errors are hard to find without PD. A lot of the failures that I've seen over the last 45 years in cabling systems have been scuffed up and torn cables being pulled through bend radiuses too tight, and the manufacturers say don't do that, and they do it anyway. And it doesn't show up until there's a little moisture induced into the situation. Then you've got a real problem. But a PD test will pick that up because it'll pick up a difference between a drain wire that has been damaged or stretched or turned. And so offline PD testing as part of your acceptance testing is a real smart thing if we have cables involved. That'll find problems with splices and manholes. It'll find termination errors, all the stuff that's usually concealed with a really nice tape job and a lot of duct seal. So lots of times you can't really see it, but it's there, and PD testing is a good way to pick it up early. Are the wall and floor connections supposed to be sealed? Are they supposed to be opened? Always question that. In bus duct testing, obviously, in the lower voltages, IR is a very good test. And the higher voltages, you've got to go with PD to really do any good. High resistant joints are the number one killer in bus ducts. A lot of bus duct today is not bolted joints that are torque wrench. They're simply break-off connections. Make sure that all that stuff is installed correctly. You can pass current through it, and then you can IR test it. You can take the two ends, loop it together, A to B, B to C, and then run current through the whole system. And if it's a 1200 amp bus duct, you can put 1200 amps on it at low voltage, IR scan it. There's lots of ways to get that. Always look for possible water penetration, as that's a very big killer.
Yeah, so one question is, please define PD testing.
PD, partial discharge, okay? There's a method that's not new. It has been used for 30 years. Signal processing, we can now process out most of the noise that were real problems 25, 30 years ago with PD testing. It was basically a factory test inside a Faraday cage. I'm standing beside probably the largest Faraday cage other than at A&M in the state of Texas. And if you go in there, there is no RF. So at our high power lab, we have a 110 picocoulombs at floor level Faraday cage. So we can go in there and do successful PD testing. In the past, it was hard to do out in the open because of all the RF background noise and so forth that distorted it. What PD testing is if you put potential AC voltage, let's say, on an insulating system, there will be a certain amount of leakage to ground. It'll work its way through cracks and crevices, and you'll see some either a skin effect or some current to ground. So you can find ways to measure that small amount of capacitive discharge. Okay. And that can be correlated to the proper amount of discharge that should be allowed, say, from conductor to the drain wires or conductor to ground. You apply a high frequency TT across the circuit. You connect that to an instrument that gathers that like a spectrum analyzer. But the new sets don't use a spectrum analyzer. They have that capacity built into them, and they have all of the noise canceling and signal processing to look for a 60 cycle pulse. So you're looking for a pulse that only occurs on a 60 cycle increment. That way, you know, it's not a radio station out of Monterrey, Mexico, or a welder next door, or a fluorescent light or something like that that's emitting a signal. So basically what partial discharge testing is looking for real small leaks of energy from your insulating system to ground, because those particular small leaks will in time create current paths, water trees, and essentially burn paths to ground and cause your insulation to fail. So if you have a system with zero PD, you have a very reliable system. And depending upon how much current to ground or PD you have will determine how far along you are in the failure of that insulating system. Feel free to reach out to me at the end. Will be my email address. I can send you some tech papers. I can call and explain this to you. This is also a test that can be done online or offline. And with maintenance testing, it's typically done online. And then in the acceptance testing world, some of it can be done offline.
I was just saying, Mose says that primary testing is extremely important for verification of ground fault systems to operate properly with switchgear mounted CTs on neutrals.
Primary injection testing is very important at all levels. And in ATS testing, you have more time to do it. So there's no reason not to push. In maintenance testing, you're up against the clock. So you have to propose a plan in maintenance testing that gets as much done to get as much sense of reliable service as you can based on the time they'll give you. And acceptance testing, quite often you have plenty of time. So there's no reason not to push primary current and check the current transformers, make sure they're not jumpered out, make sure they're connected correctly, push primary current through everything. And they're supposed to do that at the factory. If the owner sent their engineer to the factory, we build switchgear. So we have owners send their engineers and they'll spend a week working with us, pushing current and testing every circuit. We also have 7 out of 10 times the owner never comes, never sends anybody, and they basically rely on us to do it properly. So the acceptance testing people, the NETA are local contractors, their job to act as the agent for the contractor to make sure all these tests are done. And quite often the contractor or the user doesn't know everything that needs to be done. So it's basically the maintenance professional's job to ensure that the information gets to them correctly. And we're fixing to get to a slide on that. Some things to check for is, is everything grounded correctly? Are all the floor tracks welded, or is all the gear attached to the floor tracks? Quite often there's an I-beam in the floor that the gear's welded to or bolted to. Is all that solid? Do the doors open and close correctly? If the doors on the switchgear do not open and close correctly, I guarantee you're going to have problems inserting and removing the breakers, and it's just going to get worse. Normally there's a leveling pad underneath the switchgear, and the switchgear is built on an I-beam, so it should all be nice and square. Be sure that the doors open and close correctly. There's proper gaps around it. If there's not, question it. Make sure all the maintenance tools are there. I guarantee it was part of the plan, part of the bill of materials. Make sure the manufacturer got all the maintenance tools. The metal filings of the magnet test, I always carried a fairly powerful magnet in my toolbox because I was a field guy in the beginning, so I'm from that world. And after the breakers were installed, I would always go back and look on the bottom of the switchgear doors under cabinets underneath the racking devices and the mechanisms to see if there were any metal filings. If you've got metal filings after you've opened and closed the breaker 10 or 12 times and racked it in once or twice during acceptance testing, imagine how many metal filings are going to be there in a couple of years. That means there's a problem. So I typically carried a magnet for me. I would look, if I found it, I'd take a magic marker and circle the spot in the cell floor. I'd pull the breaker out and look in that spot and see what device was there. And it would tell you what was cutting those filings. There should not be any metal filings in the floor of this metal clad switchgear after you do the standard acceptance testing. Look at the atmosphere. ATM is just I'm not a great typist, so I use a lot of abbreviations, but ATM to me is, is this close to the ocean? Is it high altitude? Is it going to see really cold weather? So all the atmospheric conditions play into this. Is it a pressurized room? Is it air conditioned and heated? All these things come into place. So consider the atmosphere, consider where it's at. I've seen indoor gear accidentally applied outdoor, and if we hadn't caught it, it would have been outdoor. I've seen dry type transformers and NEMA 1 enclosures placed outdoors because someone just made a mistake. In acceptance testing, these sorts of things have to be picked up by the professional. Always look for missing components and short ship items, and then make sure that the users or the owners stay on those short ship lists and make sure they all come. You get there, the maintenance tools aren't there. You get there and there's pieces missing. Make sure that the owners realize that and they stay on it. Remediation, document everything. Nothing beats, having a notepad in your pocket. Obviously the customer says that's okay. That's all right with me. You point out a problem. This bolt's too short. That's or too long. Those are both problems. Bolt should come through in the bussing, at least a thread. It shouldn't be 3 or 4 threads too long. Okay. So if it doesn't come through a thread, or if it's 3 or 4 threads too long in medium voltage system, that's going to create a spot for Corona or PD. And low voltage equipment, if the bolt's too short, it's not going to get proper torque. So all these things come into play. You point this out to the customer. This customer says, no problem, it's okay. At that point, I document it. I have the owner's agent there, the maintenance guy, sign his name to it. They will never sign their name to it. They will then say, hey, fix it, get it right. But they will call it out that it's okay. And then if you ask them to actually document that they're accepting it in that order, almost, I'll say unilaterally every time the customer has changed his mind and decided he's going to go ahead and fix it. This is a big one here. I've been guilty of this one. Think all things through several times before you take action or cry wolf. I'm sure Mose and John know what I'm talking about here. You go out and you do a setup late at night on the weekend, a holiday, and you get a test result that is some sort of a failed test result that makes no sense. First thing you don't do is go to your customer and say something about it. You better check your setup. You better have someone else check what you're doing. You better look at your test set, test your test set, isolate everything, do it again. About the 3rd time you get a bad test, you've got a calibrated set. Everybody there has looked at your setup. You've confirmed everything's right. Maybe you've laid in bed and slept the night, went back the next day. That's when you say something, because the Portland Cement here, Tulsa PD example is an example where I quad wolf immediately when I found some failed cables. And it turned out it was a problem that I had generated. The maintenance manager had already gone upstairs with it. They were already considering remediation, and I had made a mistake. So I'm just telling you, it's a very bad feeling when you do that, and it doesn't show good credibility. So be very careful in the future, everybody. Be careful in the future. Don't cry wolf until you're absolutely sure there's a wolf that you've actually seen. The original manufacturers sometimes will be difficult. When you find a problem, expect that. But your job is to call them out. Your job's not to get in a fracas with GE or ABB or any of those guys. That's the contractor's job. So be professional there. Get the information to whoever you're working for. Whoever you're working for, whoever cuts you the PO, that's who you need to have loyalty to, and try to keep the user as a relationship in your back pocket. But basically the contractor, has to be that hired you, has to be your number one concern. Follow up. Okay. Missing components, parts of the system you haven't tested yet, things that still need to be done, failed tests that need to be redone, drive to completion, continue to work until you get everything followed up. It's very important that you have some verification of ratings. You should have a schedule of all the breaker sizes, make sure all the correct breaker sizes are in the correct power centers. I've seen them where they've installed the wrong power panels. And some of the ratings were incorrect. They were supposed to be 50 KA. They were 42 KA or 12 KA and supposed to have been 25 KA. Do you have the study set point files? are all these instruments, all these relays, all these protected devices, all these breakers are supposed to be a particular frame rating, a particular current rating, a particular voltage class, and a particular IC rating. Now, we're going to get into breakers, particularly in one of the next sessions, and I'll explain all that to you. But a circuit breaker is basically the sentinel that's standing vigilant guard over your system. And it has a voltage class, it has a frame size, it has a continuous current rating, and it has an IC rating. So this is the IC is the bursting pressure, essentially. You pass water through a valve. If the valve can't handle the pressure, it bursts. Same thing with the circuit breaker. You try to close the valve off, open a circuit breaker, there's a potential for problem. If your IC rating is not right, the voltage class is the maximum voltage that can be applied to it. The frame size is the maximum current it can handle. The continuous current rating is the value you have the breaker set to actually handle and watch below its frame rating. So the continuous current rating cannot be higher than its frame rating. I've seen that as well. Look for good workmanship. That's those eyes you've got, use them. Smell for bad smells. You can smell ozone, you can smell burning, and when you're testing the equipment, look for smoke. Don't make smoke in the testing business is normally a good rule to live by. Make sure everything's properly applied. Do you have those ratings? Does someone have those settings? The manufacturer should have them. Someone should be making sure that all the ratings are correct per the one line, per the study, per the breaker schedule that gives you all that. Whose job is proper setting verification? Quite often that's the owners has an engineer involved that'll be involved in that, and the contractor is in that loop. But sometimes it will be your responsibility if you're giving that information. So you have as found tests, and what were the settings when you found them? Were they adjusted to the proper settings, or did you leave them in those as found test conditions? Corpus Christi Petrochemical, one night, the middle of the night when I first started out, you get the call, it's raining, it's storming, and the plant's down, and we rush out there. At the time I was working for a company called BES. Remember that one, John? Thanks a lot, buddy. Anyway, when I got there, power was off, plant was dark, a refinery is dark. That's not a good sign. All the things are coking up in the pipes. Everybody's running crazy, 1,000 radios, 1,000 yellow hard hats. Everybody's mad. And, I'm 26 years old. And I'm walking to the substation with a flashlight, and I notice that the differential relay scheme, all of the taps are set kind of, in a certain matter. And there's, let's say, 369 of them in this substation. The last one I look at, all the taps are straight in a line. Well, being an ex-multi-amp guy, I realized that when you test that relay, a BDD or an HU, a BDD, you might set all the taps in one location to test, but then you put them back to the as left settings before you leave. On the last relay, whoever had tested those relays, he had left them all in the center tap and not put them back to original set point files. There was a flag on that relay. That's the breaker that tripped the plant. There had been a very popular Houston-based electrical testing company, big in the high voltage world, medium voltage world, come in and recently calibrate all the relays. Their stickers were flaming. Their technician had forgot to put those settings back. That's the sort of things you have to watch for, and that takes experience. Proper applications are the ratings per the one line in the study, whose job was to properly verify it. That'll help you prevent startup issues. It is real important, I want to say this one more time, to understand the long-term maintenance and operation of the equipment. Where's the gear located? What's the climate? What's the atmosphere? Is it indoor gear? Is it outdoor gear? Does it look like it will protect the equipment correctly for a long period of time? I've seen seams. I've seen buildings not assembled correctly where you could look through and see a gap in the edge. That's the sort of things you need to look for. Acceptance testing is testing. And, it's your job to test the equipment, to inspect the equipment, to sweep the floor and clean the substation when you leave. That's all encompassing. And believe it or not, carrying a broom with you, cleaning the gear, cleaning the windows, cleaning the placards, and sweeping the floor out, hauling the trash off, you know, that'll get you a lot of work in the future if you conduct your business like that and you take care of the substations like that. So bringing a broom and some trash bags is a great idea. Understanding long-term maintenance and operation, what the user needs, how long between now and the next test, is this gear misapplied? Are they breakers? Should they be in contactors? Are they switch fuse switches? Should they have been breakers? Is it indoor? Should it have been outdoor? Should there have been positive pressure here to keep the dirt and contamination out? We're in a cement application. That's all things you have to consider. And this time to maintenance and interval between next tests are things that you need to help educate your customer based on the atmosphere. How often do you need to test and clean the equipment? The client, basically, these long-term maintenance, ATS flies directly into long-term maintenance. And the client needs to be thinking long-term. He needs to have a maintenance manager in place. If he does, you need to assess that and you need to work with him and help make him understand what he needs to do to take care of this. He needs to have his maintenance team in place. You need to educate them, and it's now time to sell your services and sell them on the maintenance testing. Direct them to Pearl or Nita if you have a problem and you need help. Work with them hand in hand to build this relationship, because the relationship you build in acceptance testing will last forever if you handle it correctly. There are still people that call me that I was involved in acceptance testing in their plant 20, 30 years ago. So that is where you build those relationships for the future that guide you into the maintenance testing that we'll talk about next time. Proper frequency is something we can talk about for hours. Basically, we've kind of proven that after 5 years, the lubrication begins to fall off and the times and speeds and velocities of the breakers begin to slow down. So I think it's generally accepted today that less than 5 years in between maintenance cycles. If I had to pick a time, I would say the sweet spot's probably about 3, but that depends upon the atmosphere, the condition, the dirt, the type of equipment, who made it. Was it made offshore? Was it made in the US? How much maintenance testing and acceptance testing was done? What kind of condition it's in? How reliable it's been? If you've been having failures and issues, then you need to reduce that frequency, obviously. If your breaker trip times are going out, you need to reduce that. Clean, lube, and adjust is very important. The frequency and inactivity are a killer. Ask a breaker to hold it as tight as it can for many years. Okay, you're asking it to hold 1,000 foot-pounds of pressure and then to react like the day it was new. That's difficult for any mechanical system to do. You're asking a breaker to close with 1,000 foot-pounds of pressure. John, I would stand up on this chair and try to do it like you used to, but I know I'll fall off of it. 1,000 foot-pounds of pressure, 5 years, then react in milliseconds. That's what you're asking your switchgear to do. In a dirty environment, near the ocean, poor lubrication, it's not going to do it. Basically, is this a run to fail application or a situation where they're actually paying attention to some sort of condition-based maintenance? Have a good lubrication plan, do online and offline testing, always secondary versus primary testing. Maybe you can do a secondary test somewhere in there and extend the primary testing, but we always recommend primary. Talk to the customer, educate the customer, be the smart guy in the room. Our next webinar will be running into MTS type testing, maintenance testing, and then we'll get into breaker basics and advanced breaker and switchgear testing. So basically what this has been about is what do we do? What do we expect from ATS, and how do we pass that frame of mind and get out of the run to fail mentality into maintenance testing?
There was another note. Carlos was sent this note in when you were talking about the metal shavings coming off during the acceptance testing, and he mentioned arc flash causing switchgear. I'm not sure if that was a question or a statement, but I think it may be related to the metal shavings coming off inside during the acceptance testing.
Yeah. What I'm saying there is quite often when switchgear is inserted into a piece of metal clad switchgear, the equipment's very heavy, and there's a lot of energy produced in racking the equipment in onto the stabs and off. Okay. Then when the breakers open and close, there's a lot of energy exerted. They should not cut filings. Okay. By the time you get it, they've already been opened at the factory 30 or 40 times. They've been inserted 30 or 40 times. So in the bottom of the switchgear, underneath the racking device, underneath the charging motor, there should not be a pile of metal filings when the gear is brand new. We'll get into it in maintenance where you might expect to see some of that. But I always ran a magnet in the bottom of every cell. If it picked up any filings, I would bring that to the attention of the owner, because you should not have metal filings being cut by the breaker or the racking mechanism day one. If you do, it's going to develop long-term problems. So here's our contact information. Thank you very much, guys. I'm out of here. If you have any questions, we got a few minutes. I'll take them, Justin. That's it for my presentation.
All right. Hey, Finley, great presentation today, sir. At Group CBS, we want to be your go-to resource for everything electrical. Finley's a phenomenal resource for us. Thank you, sir. Make sure you check out our video library on Group CBS, our YouTube channel. And you can find this recording will be posted in just a couple of days, as well as previous webinars and the ones in the future. Thank you all for joining us today.
I'll see you all later. Thank you.